In this video, I'm going to be explaining how to write equations of lines using point-slope form. Point-slope form comes from our slope equation, which is y2 minus y1 divided by x2 minus x1. That's our slope. If I multiply both sides by this denominator, then I get this, y minus y1 equals m times x minus x1. And this is one form of the point-slope form. This is often used. We could change it just slightly by adding y1 to both sides and getting this quantity instead. So either of these are point-slope form. This last form, though, is going to be recognizable later on in math in other function forms. So you might see a times x minus h plus k, and that's because it's coming from this point-slope form, and they're just using different letters to represent these other values. So we'll use the middle one right here in this video. So what are these things in this formula? Y is going to represent any y coordinate on the line. Y1 is going to be the specific y coordinate that we're going to use when we're given a point. So we're going to substitute values into that y1 spot and leave y as a letter. M is always representing our slope. Similar to the front part here, x by itself is going to represent an x coordinate of any point on the line. But x1 is going to specifically represent the x coordinate that we're going to use when we're given a point. So we're substituting these three spots, y1, m, and x1, and we're leaving y and x as letters after we substitute. Let's see how to do that. So let's write an equation if we're given a point and a slope. So I'm given point A, and its coordinates are -3, 2. It's a point on the line, and this line has a slope equal to 2. So we're going to substitute those values into our point-slope form. x1 is going to represent the x-coordinate of the point we're using, so -3. y1 is going to represent the y-coordinate of the point we're using, so +2. And m is going to represent the slope, so m is 2. So now we just got to substitute it into our point-slope form here. y1 is 2, m is also 2, and x1 is -3. Be careful there, we're always subtracting. So if you have to substitute a negative value, make sure you're subtracting a negative. Don't just write that negative symbol once. And then we could do a little bit of simplifying here. X minus -3 turns into x plus 3. And here's our final simplified slope form, point slope form. We could also add 2 to both sides and say y equals 2 times the quantity x plus 3 plus 2, and put that over on the other side. But this is okay. So here we can notice that our coordinates are 3, 2, and our slope is 2, and we could use that to graph if we need to. Sometimes you're going to want to convert that form to slope-intercept form. So let's practice that. So using that same equation that we just came up with, we're going to solve for y and put it in slope-intercept form. So I can distribute my 2 to everything inside the parentheses here. 2 times x is 2x. 2 times +3 is +6. And then if I just add 2 to both sides, then I have solved for y, and I get y equals 2x plus 8. So there's our slope-intercept form. These two forms of the equations, they represent the same exact line. It's just different equation forms. We could use them slightly differently. Let's see what happens if we're not given the slope, but instead we're just given 2 points. We can actually get the slope of those 2 points by using our slope equation. So we'll take these 2 points, we'll find the slope between them, and then we'll be able to write the equation in point-slope form. So in using these 2 points, I'm going to say that y2 is 1 and y1 is 3, so 1 minus 3 on top. On the bottom, I want to subtract my x coordinates, so I'm going to say that y2 is 6 and y1 is 3, so 6 minus 3 on the bottom. On top, 1 minus 3 is -2. On the bottom, 6 minus 3 is +3, so our slope is -2/3. We're going down 2, right 3, in between every point. So we have a slope. We still need a point to write point-slope form. We're given 2 options here. You just have to choose one, and it really doesn't matter which one you choose. You may end up with a different point-slope form if you choose a different point, But if you simplify it and solve it for slope-intercept form, you end up getting the same slope-intercept form regardless of which point you chose. So even though the point-slope form may look slightly differently based on whatever point or coordinate pair you choose, it's still going to represent the same line. It's not going to matter. So I just happened to choose point P, but we could have chose point W and done the following. Let's substitute it into our point-slope form. My y value is 1, the y1 value. My x1 value is going to be 6, and my slope is going to be negative 2/3. So we just substitute them into the right spot, and we end up with our equation in point-slope form. We could practice putting it in slope-intercept form, solving for y. Distribute that negative 2/3 to both x and negative 6. So negative 2/3 times x is negative 2/3 x. Negative 2/3 times negative 6 is negative 2 times negative 6, which is positive 12 divided by 3, which turns into 4. So we have y minus 1 equals negative 2/3 x plus 4. To solve for y, we just add 1 to both sides, and we end up with our slope-intercept form, y equals negative 2/3 x plus 5. And if I had chosen the points 3, 3, put it into our slope-intercept form, point-slope form, and then solve for slope-intercept form, we would end up with the same exact answer. So you can go ahead and experiment on your own and see if that happens. So there's an introduction to point-slope form. It's used mostly when we're given a point and a slope, or if we're given 2 points. So we can find the slope and use a point to write the equation of the line.